Okay. It says the point Q also lies on the circle and PQ is parallel to the x-axis. Write down the coordinates of Q. Now this is very, very important. Okay. Let me give you a quick background of what exactly has been happening in this question. So we had a circle with center C and C turned out to be 4 minus 2. We were able to do that in the first part. And the radius was 5. Okay. This was basically the circle. And then P was a point lying on the circle. And in the next part, we had to find out the equation of tangent to the circle at P. We were able to do that. P had the coordinates 1, 2. Okay. Now it says the point Q also lies on the circle and PQ is parallel to the x-axis. Write down the coordinates of Q. Now I am just going to give you a rough idea about the situation. Okay. So let's say this is my y-axis. This is the x-axis. And I'm just going to make a circle roughly, regardless of the center coordinates and the radius coordinates. I'm not interested in that. The only thing I know is that P has coordinates 1, 2. So x is 1 and y is 2. So for instance, just say, let's say that this or this right here, this is basically the point P. Okay. Forget about what exactly the coordinates are, if they're negative, positive. No, I'm not interested in that. I'm just trying to explain the concept. Okay, this is point P and point P has coordinates 1 and 2. This 1 and 2 means that this x coordinate is 1 and this y coordinate right here is basically 2. Okay, now let's read the statement again. The point Q lies on the circle and PQ is parallel to the x-axis. This means that the only choice I have for Q is right here. I can have Q over here, okay? And I've been asked to write down the coordinates of Q. Okay, now obviously I cannot guess the coordinates of Q by looking at the diagram because I'm not sure where exactly P is. It could be that P is basically lying over here. And let's say if this makes the diameter, in that case, things would have been very easy, but I'm not sure. They did not specify that P is basically PQ would make diameter. No, they did not say anything of that type. P is just a point lying anywhere on the circle and Q is a point such that PQ is parallel to x-axis. Okay. So PQ is basically parallel to the x-axis. Let's see. And yes, that's true. Okay, the red line is basically parallel to x-axis, and it is parallel to x-axis because I made Q exactly in front of P because of this information. What does this imply? This implies, and the only thing that I'm able to guess from this piece of information is that the y coordinate of Q is going to be 2, right? That is the only thing I know. I'm not sure about the x coordinate. I'm not sure what exactly is here. I cannot make guesses by looking at the radius because this 9PQ is not the diameter. So I cannot say that I'll double the radius and I'll add that to the x coordinate of P. That is certainly not the case because I do not have any information of that type. Okay. The only thing I know is that the y coordinate of Q is basically 2 because Q is made right in front of P. So vertically their level is same. That is why the line is parallel to x-axis. Okay. How do I find this x coordinate? Now, in the very beginning, this equation of the circle was given. X squared plus y squared minus 8x plus 4y minus 5 equals 0 was given in the very beginning. Okay. So let me just write that thing over here. 1 second. Here it is. Okay. The equation of the circle was x squared plus y squared minus 8x plus 4y minus 5 equals 0. If I plug in this y coordinate over here, I would get an equation with x only, and I would get the x coordinates according to the y coordinate, okay? Because point Q is lying on the circle. So if I plug in this in the equation, I would come across 2x coordinates. And those 2x coordinates would basically be those where we would be having 2 as the y coordinate, right? Let's simplify this and then you'll get the idea. We know that y is equal to 2 at Q. So it would become x squared plus 2 squared minus 8x plus 4 into 2 minus 5 equals 0. X squared plus 4 minus 8x plus 8 minus 5 equals 0. X squared minus 8x. Okay, this is plus 4 and plus 8 is basically 12. Minus 5 would make it minus 7 equals 0. Now we need to just factorize it. So two numbers such that when I multiply them, I should get minus 7x squared. And when I add it, I should get minus 8x. Okay, can anyone guess the factors for this case? This is plus 7x, okay? That's obviously minus 7 and minus x. So it would be minus x and minus 7x plus 7 equals 0. I can take x common and this would give me x minus 1. Minus 7 common and x minus 1 equals 0. And this is giving me x equals 1 and x equals 7. So now I'm getting two x coordinates. Which x coordinate should I consider for this case? Can anyone tell me?
7.
Very good. Excellent. Okay. Because I know 1, 2 was already used for P. This point P is also lying on y equals 2. So this one is basically for P and this 7 is basically for Q. So this is going to be 7 and it is going to be 7, 2. This is going to be the answer. Okay. Yes. Any difficulties here? Any confusion, Rafe?
No, miss.
Okay. All right. Perfect. Okay. Now let's talk about the third part over here. And it's the fourth part basically. It says the tangents to the circle at P and Q meet at T. Find the coordinates of T. Okay. Now we know that we can easily find the coordinates of T if I have the equation of both these tangents, right? I do have the equation of the first tangent, that is tangent at P. Show that the equation of the tangent to the circle at P is 4y equals 3x plus 5. I have this one. So the equation for this was 4y equals 3x plus 5. And now we need to find the tangent at Q. And this is what I would want you guys to do, because I've just told you when you have a point lying on the circle, you can easily find the equation of the tangent, okay? This was basically the method. Now I'll write down the coordinates of Q. Q turned out to be 7, 2. Q has coordinates 7, 2. I'll wait for 2 minutes. Please find out the equation of the tangent at Q, just like this one, just like we did in the beginning of this class, and then we will solve both the equations simultaneously. Okay, so forget about the second part for now. Your task is to find the equation of tangent at Q. Both of you, Munja and Rafe, I'll wait, okay? Please do it. Yes, anyone who's done? You can tell me the question directly if anyone is done. And it's completely fine if your answer. Yes, yes.
3y is equal to minus 4x plus that 4.
Sorry, say it again.
3y is equal to minus 4x plus that 4. That's what I find.
Okay, and Rafe, what did you get as your equation?
Miss Verity.
Okay, okay, sure.
I'm getting y is equal to 3 over 4x minus 3.25.
Okay, all right, okay. So let's see what exactly we are going to get. Okay, all right. Now, again, we have the point. We need to find out the gradient for that. I will use 4 minus 2, the center, and 7, 2 in order to just find out the gradient of the perpendicular line. So this would give me m equals h2 minus 2. Again, this coordinate is 2 and this is minus 2, right? So y2 minus y1 divided by x2 minus x1, and this would give me 4 divided by 3. 4 divided by 3 is basically the gradient of the perpendicular line. I'm not interested in that gradient. I'm interested in the gradient of tangent. That would be minus 3 by 4. So m is going to be minus 3 by 4. Okay. Now I am just going to erase it. And I'm just supposed to simplify it. So this would give me y minus 2 equals m x minus 7. And this is going to give me, I'll directly take this 4 on the other side. So 4y minus 2 equals minus 3x plus 21. 4y equals minus 3x plus 21 plus 8. And this is going to give you 4y plus 3x equals 29. Okay, 29. So you guys can check your equations again. After simplifying, you should get the same thing. Okay, this is
Okay.
equation 2 and this is equation 1, and now we have both the equations for both the tangent lines. Now what was the question? The question was about that P and Q meet at T. So you were asked to find the coordinates of T, and that's very simple now. For Q, we got 4y plus 3x equals 29. So this is equation 1. This is equation 2. You're just supposed to simplify it simultaneously and you would get the answer. So can you guys give it a try?
Miss, Miss, can you
Yes?
go up?
Yes,
Miss,
definitely.
can you go to the parts?
C part?
Um, Miss, the place where you did the work.
Oh,
Right.
yes.
Miss, why did you write the gradient as -3 or 4? It is 3 or 4, right?
No, but I'll tell you why. Because I've erased that part because when I calculated the gradient using of the perpendicular line, that turned out to be 4 by 3. Let's do that again.
Miss, it's that it's -4 over 3, right?
No. This minus 4 over 3 is basically the gradient for the previous scenario. This was the gradient for like this line, right? When I was
Mm.
finding the tangent at P. For Q, I did separate working. For Q, this is the point, right? So if let's say, if this is point Q, I'm just saying this won't be point Q, but let's say if this is, or let's talk about realistic stuff then. Let's say if I have point Q somewhere here, for that, I will talk about this line and I will find out the gradient of this line now using the coordinates of center and the Q, point Q, right? For P, I used P and center. P was 1, 2 and center was 4 minus 2. For tangent at Q, I will use Q and center. Are you getting this thing?
Yes, Miss.
Okay. So when I will use 7 and 2, I would get 4 by 3 as the gradient. And then when I will take the negative reciprocal, it would be minus 3 by 4. Okay. Just take your time and find the gradient according to this. I'll wait, no problem. Just let me know once you're done. Okay.
Okay, Miss. Okay, Mister.
Okay, great. Okay, perfect. So now the thing was that we are going to solve these two equations simultaneously. Why? Because we are interested in finding out the point of intersection, and for finding out the point of intersection, we solve equations simultaneously. Okay. So that is basically the idea. So let's try doing it. We have multiple ways. Everyone has their own method. You can do it by elimination. I would say that's better, but you can also do it by substitution. So I can write down equation 2 as 4y equals minus 3x plus 29. Now I have 1 and equation 2, this one. And now what I can do is I can just do 1 minus 2. Think about it as equation 2. This is for Q. And now things would be easier. Okay. Let me just do 1 minus 2. So equation 1 is 4y minus the left side of equation 2, that's 4y, then 3x plus 5 minus the right side of the equation 2, that's minus 3x plus 29. So these two would be cancelled. It would give me 0 equals 3x plus 5 plus 3x minus 29. And after simplification, I am going to get 0 equals 6x minus 24. And this would be 24 equals 6x. And x is going to be 4. Now x is 4, I can use equation 1, 2 to find out y. So I can do it this way. Equation 1 implies y is equal to 3x plus 5 divided by 4. So what I can do is I'll just plug in x equals 4 in this equation, and this would give me y equals 3 multiplied by 4 plus 5 divided by 4, and it's 12 plus 5 divided by 4, and this would give you 17 by 4. So it is y equals 17 by 4, and this is going to be the answer. You were asked to find out the coordinates of t, and the coordinates of t are going to be 4 and 17 by 4. Okay? Yes. Any confusions with this?
No, Miss, everything's clear.
Okay, perfect. So